Hey guys, so I am not here today, so I thought it might be a little easier for you if I made a video, so that way I'm kind of talking through my notes at the same time, and it's a little easier for you to understand. So make sure that you have your notebook out and you are copying all this stuff down in your notebook as I go. So we will be covering Chapter 3, Section 7. Okay, so today we're going to be covering Chapter 3, Section 7. So the first thing that we have is our essential question is how can I identify the type of function? So we have three different types of functions that we can have. So our first type of function is our linear function. So our linear function is the one that's the y equals mx plus b. So remember when we're talking about our linear function that m stands for slope, which is our rise over our run. So rise is going up and down, run is going left and right. Then we have b. B is our y-intercept, and it's always located at 0, b. Now, it's called a linear function because the word linear means line. So if we were to go and graph this, we're going to end up with a graph that looks like this. So our graph could look like this, where it's going up. This would be a positive slope, so it goes up to the right. It could be a negative slope, meaning it's going down to the left, or it could be horizontal, which means it's going left and right. So there is our first type of linear function, or our first type of function. It's linear, y equals mx plus b, m is our slope, b is our y-intercept. Okay, our second one you may not be as familiar with is our exponential function. So exponential uses this equation of y equals a times b to the power of x. Now, our a is our y-intercept, where it's crossing that y-axis. So our y-intercept is going to be at 0, a. B is our common ratio. What number are you multiplying by each time? Now the b in our exponential is not the same as the b in the linear. So you have to decide, are you working with an exponential function or a linear function first, and then decide which b you're talking about. Because b for our linear was our y-intercept, b for our exponential is our common ratio. Now when you graph a exponential function, it's going to look something like this, where it's kind of like a J shape. It's a curve. So it can go like this, where it starts out small on the left and then it gets bigger as you go to the right. Or it could be going the opposite direction, where it starts out big on the left and it gets smaller as you go to the right. So those are our first two types of functions, and I will give you just a minute or two to get all of that copied down. We do have one more type of function that we'll be talking about, and that is our quadratic function. So our quadratic is what we've been working on like the last 2 or 3 months. So that's our y equals a x squared plus bx plus c. So remember, our a tells us whether it's opening up or down. If a is positive, it's going to open up. If a is negative, it's going to open down. Our whole number, if a is a whole number, tells us it's a vertical stretch, which means it's going to be skinny. And if a is a fraction, then it's a vertical shrink, which means it's going to be wide. B doesn't really give us any sort of information that we can just see. So we're going to move on to letter C, and letter C gives us our y-intercept. So that's going to be at 0, comma, C. So I'm going to write that 0, comma, C. Okay, we've been talking about how to graph these quadratics for a while now. And so to graph these quadratics, they're the ones that form our parabola, our U shape. Remember, it can open up like this, or it could be opening down. So I'll go ahead and let you have a chance to get this all copied down. If you need to, you can go ahead and pause the video and let the students copy it down before we move on. Okay. So the first thing that we're going to do is we need to graph the points and tell whether they appear to be linear, exponential, or quadratic. So remember, linear is going to form that line. Exponential is going to form the kind of J shape or the curve. And then our quadratic is going to form our parabola, our U shape. So our first set of points. So right here, number 1, we have 4, comma 4, 2, comma 0, 0, comma 0, 1, comma negative 1/2, and negative 2, 4. Remember, the first number is your x, which is left and right. The second number is your y, which is up and down. So when you go to graph that, you should come up with this. This is a parabola, which means it's going to be a U shape. Okay. Number 2. We have 0, 1, 2, 4, 4, 7, negative 2, negative 2, and negative 4, negative 5. So go ahead and graph these 5 points and decide what shape does it make. So are we working with a linear, a exponential, or a quadratic function? So when you graph that, I changed my scale a little bit so I could fit it on my page. I came up with a straight line, so I labeled it as linear. I'm making each box worth 2. Okay, number 3. We have 0, 2, 2, 8, 1, 4, negative 1, 1, negative 2, 1/2. So go ahead and graph those 5 points and then decide, is that going to be linear, exponential, or quadratic? For this one, we end up with this kind of J shape, which means it's going to be exponential. So here are our first 3 problems all together so that you can see them. So as long as you graph it correctly, graph your points correctly, you should be able to tell what kind of function you have from the shape, whether it's quadratic, the parabola, linear, the line, or exponential, the curve. So next we're going to look at differences and ratios of functions. So basically what that means is we're going to look at how can we tell from a table if a function is going to be linear, exponential, or quadratic. So the first thing that we have is if it's linear, then the first differences are going to be constant. The first difference or differences are constant for a linear function. And we'll talk about what that first difference means. Constant means the same. Next we have exponential. So if it's an exponential function, consecutive y values have a common ratio. So remember, ratio is what you're multiplying by. So that means you're going to be multiplying by the same number each time. Our third option is quadratic function. And for quadratic function, we have the second differences are constant. So linear was first difference are constant. Exponential, consecutive y values have common ratio. And quadratic function, the second differences are constant. So now what we're going to do is we're going to look at some tables and we're going to talk about how do you figure out whether it's linear, exponential, or quadratic. And then after you decide which one it is, how do you write your equation in standard form that goes with that particular table. So determine if the table represents linear, exponential, or quadratic function, then write the equation. Now I did use some colors on this, so if you have your own colors, you can get them out and use them. I used a total of 3 colors besides my pencil in this problem, or in these problems. So we already looked at examples 1, 2, and 3, so this is going to be example 4. So all we have right here is x is -3, -2, -1, 0, and 1. Y is 11, 8, 5, 2, and -1. So first thing we have to do is we have to decide, is it going to be linear, exponential, or quadratic? So I always check linear first, so I check the first difference. So I check the top, my x values, and they are all adding 1. To get from -3 to -2, I add 1. -2 to -1 is add 1. -1 to 0, add 1. And 0 to 1 is add 1. For my y values, 11 to 8 is -3. 8 to 5 is -3. 5 to 2 is -3. And 2 to -1 is -3. So I know that my first difference, this would be my first difference here, is constant. So I know it's going to be linear. Now, if it's linear, I have to know 2 things to build my equation. I have to know what my slope is, and I have to know what my y-intercept is. So I know my y-intercept is my b value, and it's always paired with x equals 0. So I found on my table where x equals 0, and my b is my y value, which is 2. B is always paired with 0. So I know my b is 2. For my slope, I do my difference. So it's really going to be -3 over 1, but -3 over 1 is just -3. So this is my m, my change in my y's. So I have y equals -3x plus 2. And there is my linear table. Okay, number 2. I guess this is number 5. So our table is x on top. We have -2, -1, 0, 1, and 2. For our y values, we have 1, 2, 4, 8, and 6. So I check my information first. So my x's to -2 to -1 is add 1. -1 to 0 is add 1. 0 to 1 is add 1. and 1 to 2 is add 1. So my x's are all changing by 1. On my y's, to get from 1 to 2, I multiply by 2. 2 to 4 is times 2. 4 to 8 is times 2. And 8 to 16 is times 2. So I have a common ratio because I have a common number that I'm multiplying by. So I know it's going to be exponential. Since it's exponential, I need to figure out my a and my b. A is my y-intercept. Our y-intercept is always paired with our x equals 0. So in my case here, we have 0 is paired with 4. So a is going to be 4. Our b is what are we multiplying by at each step? At each step, we are multiplying by 2. So I have y equals a b x to the power of x. So I'm going to replace my a with 4 and my b with 2. So our final answer is y equals 4 times 2 to the power of x. And there is our exponential. So I know I said that I used 3 different colors. In my next one, I will have a third color added on. Okay, so here is example 6. So first thing that we have is our problem. On the top of our table, we have x, and then we have 0, 1, 2, 3, and 4. For y, we have 12, 0, -4, 0, and 12. So I notice that all of my x's are going up by 1. 0 to 1 is plus 1. 1 to 2 is plus 2. 2 to 3 is plus 1. Plus 1, plus 1. And 3 to 4 is plus 1. So then I check my first difference. To get from 12 to 0, we subtract 12. 12 to -4 is -4. -4 to 0 is plus 4, and 0 to 12 is plus 12. So my first difference is not constant. So I check my second difference. -12 to -4 is plus 8. -4 to 4 is plus 8. And 4 to 12 is plus 8. So our second difference is constant. Since our second difference is constant, we know that this is going to be a quadratic. Now remember, when we go to build our quadratic equations, we can't go straight to our standard form. We either have to use vertex form or we have to use factored form first. So what I would do is I would look back at my table, and looking at my table, I can see that I have x-intercepts because I know it's an x-intercept if my y is 0. So I have 1, 0 and 3, 0. Since I have my x-intercepts, I'm going to use my factored form. So remember, our factored form is our y equals a parentheses x minus p, close your parentheses, parentheses x minus q. Now remember, this p and this q are opposite signs from our table. So I had a positive 1 in my table, which means I'm going to write a -1. I had a positive 3 in my table, which means I'm going to write a -3. So we get y equals a parentheses x minus 1, close your parentheses, parentheses x minus 3. Now I have 2 variables left. Or, well, I technically have 3. I have x, y, and a. I need to know what this a value is. So to find this a, I pick any point from my table. And so I used this first point that I labeled in green, or I circled in green. I'm going to change all of my x values to 0. I'm going to change all of my y values to 12. So we have 12 equals a times 0 minus 1 times 0 minus 3. So I'm just going to simplify and I'm going to start solving for a. So 0 minus 1 is -1. 0 minus 3 is negative 3, and when I take negative 1 times negative 3, it gives me a positive 3. So I have 12 equals a times 3. Well, I divide by 3 on both sides, and that's going to give me that a equals 4. Now that I know that a equals 4, I'm going to rewrite my equation with it plugged in. So we have our equation is y equals 4, parentheses, x minus 1 times x minus 3. Well, our goal is to solve it and put it in standard form. We have it in factored form, so we talked about how to get it in standard form. So first thing I'm going to do is I'm going to multiply my x minus 1 and my x minus 3 together using my Punnett square. So along the top I have x minus 1, I have an x minus 3 down the side. X times x gives me x squared. Negative 1 times x gives me negative 1x. X times negative 3 gives me negative 3x. And negative 3 times negative 1 gives me positive 3. I need to combine my like terms, so my like terms are always along my diagonal. So I have a negative 3x and a negative 1x that are like terms that I can put together. So I end up with y equals 4, parentheses, from my Punnett square, or my table, I get x squared minus 4x plus 3. Now that I have that, I need to distribute this 4 to everything inside my parentheses to get my final standard form. So we have 4 times x squared gives me 4x squared. 4 times negative 4x gives me negative 16x. And 4 times 3 gives us 12. So we came up with, this is our final answer, and this was quadratic. So hopefully now you can tell from a graph whether it's going to be linear, exponential, or quadratic. You should also be able to tell from a table whether it's linear, exponential, or quadratic. You should also be able to come up with the equation if you have a table. So that is the end of notes for section 3.7.